Welcome to the third video on the content fixing the limit of integration in double integrals. So in this problem, we will fix the limit of the region which is bounded by the line y equal to 0, the line x equal to 1 and the curve y square is equal to 4x and which happens in the first quadrant. So when we are able to draw the diagram or plot the given lines and curves, then we will be able to fix the region of integration, and once the region is known, then we can fix the limit. Keep recollecting that the limit can be fixed in two ways, either in the direction of x or in the direction of y. So we will begin the task by first plotting the given lines and curves. The first thing to go over is going to be y equal to 0. As we have already told you, always keep two colors for plotting so that you differentiate between the given boundaries and the imagined boundaries or imagined lines. Now our axis, so let us go for the x-axis and y-axis. X-axis and our y-axis. Okay, so we have our x-axis and y-axis. Now let us plot the first line, which is y equal to 0. So what is y equal to 0? Y equal to 0 is nothing but our x-axis. So let us plot this line y equal to 0. While plotting, use a different color so that you will be able to differentiate the given line and the bounded line. So this is my y equal to 0. What is the second thing which I have? The second thing which I have is x equal to 1. How does the line x equal to 1 look like? So x equal to 0 is our y-axis. So x equal to 1 will be a line which is parallel to your y-axis and which is at a distance of 1 unit. Okay, so from the origin, let us fix 1 unit, and from the point 1 unit, draw a line parallel to your y-axis. So x equal to 1, 1 over here and 1 over here. So this will be 1 units in my x-axis and 1 units in my y-axis. So I want x equal to 1. This is going to be your x equal to 0 and my x equal to 1 will be a line parallel to your y-axis. So let us have a line that passes through the point 1, 0. So this line which we have will be called by the name x equal to 1. So since this is going to be a line which we draw, let us make it in red color to denote that it is going to be the bounded line. So this is my line x equal to 1. Next we move on to the third quantity given to us, y square is equal to 4x. What does this y square equal to 4x represent? As we know, when it is going to be not a linear, this is going to be power 2. This is not going to be a straight line, but it is going to be a curve. So what does this equation represent? This is a curve which is called by the name parabola. We have 4 different kinds of parabola, and this parabola, which is of the format y square is equal to 4x, is one which is open to your left. Okay, so we will try plotting the parabola. How will this parabola look like? It will be something like this, a curve touching your origin and moving this way. So this is my parabola, y square is equal to 4x. Now the next point is find the region of evaluation of the integral. The region is going to be bounded by these two lines, this curve, and which lies in the first quadrant. What do you mean by first quadrant? The portion where x and y both of them are positive is called as x quadrant. So which is our region of integration? The region of integration in the first quadrant is this portion over here. So this is my region of integration. Now we have the region of integration. We will have the end points plotted so that it will be easy for us to fix the limits. Now let us fix this point. What is this point? It is the origin which is given by 0, 0. The next boundary is this point which is the intersection of the line x equal to 1 and y equal to 0. Therefore, the coordinates will be 1, 0. The next thing which we want is this point which is going to be intersected by the parabola and the line x equal to 1. So, we have the parabola y square is equal to 4x, and what happens? The line x equal to 1 passes through the parabola. So, put x equal to 1 in the given parabola. So, what will happen? Y square is equal to 4 times of 1. This gives me y square is equal to 4, and so I will have y equal to plus or minus 2. So, what is the point y equal to plus 2? Y equal to plus 2 will be the topmost point, and y equal to minus 2 will be the bottommost point. So, this point is y equal to 2 and this point is y equal to minus 2. The region where we have to evaluate is only in the first quadrant. Therefore, we take only the portion which is there in the first quadrant. So, which is the portion in the first quadrant? It is the line y equal to 0, the line x equal to 1, and the parabola which is given by y square is equal to 4x. And this is bounded by x equal to 1, y equal to 2. So, this point will be 1, 2. This point will be 0, 0, and this point will be 1, 0. So, keeping this region R, we are now going to fix the limits. So, how to fix the limits? So, we will move to the next slide. The values for so this is going to be my y equal to 0, y equal to 0, this is my x equal to 1, and now we have the parabola. What is the parabola? This is going to be the parabola which is given by y square is equal to 4x. The point 1, 2, the point 1, 0, and the point 0, 0. Now let us fix the limit in the direction of x. In the direction of x. So what is the rule? Draw a strip which is parallel to your x axis. And what is the direction of your x axis? Move from left to right. So this is the direction of x axis. Now let me fix a strip parallel to my x axis. This is my strip parallel to x axis. So this becomes my starting point of my x. Y square is equal to 4x. So y square divided by 4 is my x. Therefore x begins the journey at the leftmost value. What is the leftmost value? X is equal to y square divided by 4. And what is the rightmost value? It moves and it reaches the value x equal to 1. So the variable limit for x is y square by 4 to x equal to 1. And now coming for the constant limit of y. What will be the constant limit of y? It is the total height variation of y. So check for your y coordinate. Where does your y vary between? The second coordinate is y. So y varies between 0 to it reaches the topmost point called as 2. Since we integrate the function f of x, y with respect to the variable x first and then followed by it the variable y. Now this is in the direction of x. Now the same problem can also be done in the direction of your y. So for the direction of y, what we'll have to do? You will have to draw a strip which is going to be parallel to your y-axis. If I draw a strip parallel to y-axis, then how do we move in the y-axis? In y-axis, we move from the bottom to the top. Okay, we move from the bottom to the top. So what you'll have to do is draw a line parallel to your y-axis, which is the bottom line for y equal to 0. From here, I am going to draw a line parallel to my y-axis to reach the curve at the top. So this is my strip. Now come on, let us fix the limit. What is going to be my lowermost limit of y? The bottom limit of y is going to begin with y equal to 0. It moves and reaches the point y square is equal to 4x. If y square is equal to 4x, so what will be the value of y at this end point? So y will be plus or minus square root of 4x. But since we are dealing only in the first quadrant, we will have y equal to positive square root of 4x and ignore the negative quantity. We know that square root of 4 is 2. So your limit will be moving from 0 to 2 root x. So this is my bottommost point. This is the topmost point. Hence you move from 0 to 2 root x. And now coming for the constant limit of x, where does our x begin? X begins with 0 and it ends with 1. So x varies between 0 to 1. The function gets integrated between your limits of y equal to 0 to 2 root x and x equal to 0 to 1. First with respect to y and then with respect to x. So this is the way in which we fix the limits either in the direction of x moving from left to right or in the direction of y moving from bottom to top.